Well, good evening. My name is Wenming Yi. I am a product manager at Google Cloud. And how many of you have used GCP? Quite a few. Okay, great. And before I joined Google, I never really tried to, I never really used GCP very much. So one of the interesting things about me is that I worked at Microsoft, AWS, and here at GCP. So if you have any questions about all of these things, all these places which I've worked at, love to be able to answer them. So at AWS previously, I worked as a science manager. We ran a, how many of you heard of MX Next? MXNet? Quite a few of you. So we also built a few things called things like AutoGluon, which is quite popular. Some of you have used it, I guess. Okay, fantastic. I'm really glad that you have. And AutoGluon is turned out to be one of the most popular open source tabular frameworks. So I used to own a team that runs it. There's still a team that is continuing to build on top of it. We've also recently released a time series foundation model called the Chronos, if you have heard of it. So definitely check it out. And I'll put some links up in the after I finish the talk. So one of the things that I wanted to, kind of talk about is models. So we are in the world of generative AI, and it's kind of an arms race. So how big is the largest known model in terms of parameter size we know today? Does anybody know? Everybody? Okay. What about the largest open source one that we just, recently just released? That's right. So the 405 billion parameter llama model that we just released. So I worked about 4 weeks, 7 to 11 every day, and just actually shipped it. So it's now available in Vertex Model Garden. So love to have you guys all try it out. So let me kind of talk a little bit about from the beginning. So we had a transition from machine learning into generative AI, and the transition is very sudden. And I think just one day, I think somebody, one of my bosses just calls me and says, okay, we're dropping everything. We're going to do Gen AI. And it has been very exciting, right, so far. So I joined Google mostly wanted to work on Gemini and some of these, models. And I was very lucky to have the opportunity to work on some of them, especially the open source ones like Gemma, which I will talk about in a minute. So this is what's new. Google Gemini 1.5, there's a August 1st version that was set to be #1 in the chatbot arena in the LM Assist. So it's the best model, known model that is available to you for you to use. And if you cannot afford to have to run a model that is a few trillion in parameter sizes, we also offer the open source 2 billion parameter model, which is really good in performance, but you will be able to run that on your laptop. So how many of you have tried Ollama in some of these? Okay, and also Llama CPP and those things. So you could actually run these models on your laptop with relatively good performance without having to necessarily make these API calls. So it provides you with these both of these options if you are looking for some of the largest models that's available and some of the smallest models that you could actually fit on your phone. And by the way, this Gemma 2 model fits on your iPhone. I've seen actually demos of people running it on your iPhone. So this is another just a big picture. Llama 3 was released in April, and we just released another, they just released another version, 3.1, with the 405 billion parameter model in July. And there's rumors that there's going to be even bigger models that's ready to be released. And also DBRX is a MOE model or mixture of expert model that was also released. As you can see, there's literally a lot of models that are being built. 5.3, so we are in the Microsoft Office here. So the 5 models are also excellent, and they're just fantastic in terms of practicality, being small models. There's a lot of talks about how smaller models are actually quite capable. Polygemma is one of the multimodal models that Google also released as completely open source and free. And of course, Gemma has released an update. There's a 2 billion parameter, there's a 7, and then there's like a 27B parameter model that we've released. So as you can see, there's a spectrum of these models from these commercial models that are trillions in parameters that you can't really host yourself. And I can tell you how many nights I kind of stayed up trying to get the 405B to fit into a H100 host. So you all have lots of fun if you were trying to do that. So this is actually a picture of a Hugging Face. Currently, I think there's like 900,000 models there. It's not really about how many models we have, and I'm pretty sure no one has tried all of them. But what's interesting is that the number of people that are able to fine-tune a base model and create that ecosystem just shows you there's so much work and so much time and GPUs that are being spent on this industry about building models. And this is where the energy is in terms of innovation. So that comes down to, what is the first step of generative AI? And after I joined Google, I think the first thing I wanted to build is to build out that discovery capabilities. So how would you build that, right? So how would you bring, since there are 5 models coming out every hour now, so how do you build something that is up to date and not, also get your engineering really mad, asking them to onboard a model every 5 minutes. So that's not really sustainable. So we did a few interesting things. The first thing I did is that we did a really good two-way integration with Hugging Face. This is something we're actually doing. And I can show you a demo in a second. And the second thing is that we want to do model as a service because there's no way that people are going to be having thousands of people each deploying their own H100 times 8 nodes. And this is going to be very expensive for people to be able to do. One of the key things I do want to talk about is the orange line at the very top. So in the more traditional machine learning, and I just wanted to keep reminding everyone, the reason we are here doing generative AI is that you can bypass tuning and training in general. So before, you're going to need your data scientists to be able to do things. It takes days and lots of time. So the AutoML framework that I helped to build at Amazon, that kind of bypassed it. So we essentially provide 3 lines of code beating 99% data scientists, and it's still #1 on Kaggle. But the problem is that you still need some science capabilities. The reason we're here is that you can completely bypass that. As the models become more powerful, you do not need to fine-tune these models anymore. That's why they're so powerful, and you can directly access these models and do amazing things and build amazing things on top of it. So that is the reason why we're all here. And here are some of the models that we provide, and it says 150. There's really about 5,000 models in Model Garden right now. So as you can see, it does grow quite fast. So Gemini 1.0 Pro and 1.5 Pro, so those are kind of the workhorses, and a lot of people use that. And we also recently introduced Gemini Flash, which is very inexpensive. These are essentially the I think there are about 8 billion parameters, but they're really, really good. And you can essentially call the APIs directly. They will also have these foundation models that we provide. Some of them are a little older, but we also now have ImageN 3. We have Chirp and some Cody and embedding models. We also have some, Google research provided specific models. There's some geo foundation models that we're providing, and then there's things like, forecasting, time series, foundation models, and so on. And on top of it, we are, this is, my main focus now, which is to onboard a lot of these open source models. As you can see at the very bottom, so we onboarded the 405B model into Model Garden, which is the largest model that's available. And, a lot of other cloud providers also, did the same thing. So, but the good thing is that I'm making them free until I don't know when, but for the next 2 months, it will be completely free. So definitely take advantage of it. I can tell you it costs a lot of money to host these things because H100s are not cheap to run. So if you were to remember just one thing today, go to Model Garden, get your free API calls. So definitely, and we are actually hosting the 405B directly, and it's free. So that's one thing you need to remember. In terms of other things that we're providing, Gemma is a very good lightweight model people fine tune. So I see lots of people fine tuning these models. And I would say probably there's like at least 30% of the people that are using Model Garden are essentially fine tuning these models, and there's probably another 20–30% people are fine tuning these llama models, as we can see. So people really love open source models and just want to really kind of use them and by adding their own data and fine tuning them. And of course, I added the Hugging Face integration, which allows you to take any of the TGI compatible models. So TGI stands for text generation interface. So it's essentially a container and a library that allows you to be able to run any of these models that are supported by this container. And you can do it, from Hugging Face. You can certainly do it from the Model Garden. That makes it really easy to do. So Model Garden, Vertex have a few other parts of it. So given the interest of the time, I'll go through, I would just mainly focus on the discovery phase, which is the Model Garden, and how do you actually run some of these models. Yeah, so there's no one size fits all for enterprise AI. So I'm seeing people, teams that would actually use up to about 20 different models, and they want all of them in the same place. So that's one of the interesting things about generative AI is that people want to have access to a lot of these different models. So this is essentially a screenshot of the latest in Model Garden. We're continuing to improve it. And one of the most impressive thing about working at Google is that we have amazing UX and designers. I've never worked at anywhere else that had as talented folks that are designing things for me. So that's just been a super pleasure for me to work there. So there are a lot of criteria for model selection. So the question becomes, when do you select a API-based model versus when do you select a model and run it yourself, right? I think the key thing is, for most people, these API-based models are so good now that you almost would not ever need to do something yourself, unless you have very specialized data sets that you want to fine-tune yourself. And as the models get actually larger, so the 405B model, I challenged one of my teams to fine-tune it with data that can actually make the performance go up. A week and a half later, I haven't heard back from them. So as these models get larger, they become really good. So you can essentially use them directly, and it would be very rarely you would want to fine-tune them. There's a few different things I wanted to cover. There's all these different tasks that you would use for Gen AI. But in the world of Gen AI, a lot of these tasks are essentially supported by Gen AI. So you no longer have to build these, use these API-specific things. So one thing I do want to call out is AutoGluon. So if you are still interested in learning traditional machine learning and you don't want to spend a lot of time and you want to work on business applications, AutoGluon is still probably the best. Actually, there's no competition. This is like the best AutoML framework there is. So if you're dealing with any kind of tabular data, GenAI doesn't cover tabular data. If you want to do that, definitely learn it. Go down to the website and look at the cheat sheets. It takes you a few hours to learn, and then that skill set stays with you, and you can talk about how how you spent, write 3 lines of code beating 99% of data scientists. We're currently on Kaggle. There's a lot of competition on it. We're, by far the most powerful AutoML system that is there. So it replaces XGBoost and all these different systems by using very powerful ensembles. So if you are dealing with any kind of tabular work, definitely learn it. And with the combination of GenAI and tabular work that you know how to do, you would be able to accomplish a lot of great things. I'm not going to go into too much of these ML ops type of work, but in essence, whether it's SageMaker from Amazon or Vertex AI from GCP, so most of these systems actually support these type of custom deployment and training type of ML ops workflow. And some of them, like I said, for those of you who are still tuning your own models, so these systems are still supported. But like I said, again, in GenAI, your focus is no longer about necessarily the tuning part. It's really about building applications, building agents, and building things that runs really well on top of it. I do have a demo, but I know that we probably, how much time do I have? We're good. Okay, great. Yeah. All right, great. So this is essentially stuff that we actually support in terms of Hugging Face. So we support all the models you want to deploy that are TGI container supported. You will be able to deploy them into Model Garden. So essentially, these are VMs that you would automatically pick for you. So we provide that as a very strong convenience for people. So if you're a data science person and you want to play with these open source models, we provide this integration. And additionally, we offer the integration from the Hugging Face site. So if you go to Hugging Face, you will be able to deploy a model from their website, and it will have a GCP button somewhere in here. I found it. It's right here. So it's a few lists down. So you would be able to click on it, and we'll go to Model Garden and deploy it for you. And the good thing is that we have quite a bit capacity. Used to be that I had to go find capacity for customers, but right now I have quite a few capacities. You will be able to deploy successfully. So quite a few other cloud providers, they're running out of capacity for a certain type of GPUs. So I'm going to run this really quickly so that you can have a feel. Even though this is a couple month old, I just didn't have a new video yet. So it kind of gives you a live of what you can what we support. So by the way, for some of the third-party models, we support cloud. So there's Haiku, there's Opus, there's Sonnet. What was the other one that people remember the name from? No, not Mistral. The Anthropic models. Yeah, cloud. That's right. That's right. So all the different cloud models that we support. We also support Mistral. Great call out. So Mistral Large is actually now available on Model Garden. So it's actually, we provide all these different ways for you to be able to search. So you can search for a model, and if it's on Hugging Face, if it's the most popular ones, you'll be able to find it, and then you can essentially deploy it. So essentially the one-click deployment. When I first joined, and I thought, what would it take for people who don't know systems very well and machine learning very well and have them actually successfully deploy a model? So coming from Amazon, my only idea is one-click something. So this was the one-click deploy that turned out that people really loved it. So that's our one-click deployment from Hugging Face and so on. But I'm sure we provide like free credits on Google Cloud, so definitely try it out. And also the Llama 3 405B model is actually free, and we can just go on there and play with it for a second after this video is done, I guess. Yeah, so we do work very closely with Hugging Face, and I think one of the key thing about Hugging Face is that they're kind of religiously love open source, and so do I. And we'll continue to support a lot of these models. So as far this morning I was talking to my dev team, and I said, how many models do we have we actually tested and now verified? For sure, they said 5,000, and I said, wow, that's quite amazing. But we also use heuristics to allow you to deploy any of the 100,000 to 1 million models that you would be able to deploy using heuristics. If you're interested, I'm very happy to send you how we calculate some of these things. So, for example, you have to know what the parameter size is. You have to know what KV cache size is. You have to know how many these KV heads you're using, and among other things. So you can pretty much calculate how much GPU memory you're going to need and determine how big of a deployment to actually run based on any model size. So in terms of tuning and other things, I keep emphasizing on the this giant blue arrow, which is in the world of Gen AI, you're saved from having to do that difficult science work, and you kind of go directly to innovation. So I think that is a very important aspect of it. But if your job is to do science, you also have the opportunity to play with so many of these newer models, and you can find the right size, fit them for your specific needs. So for example, I had one of the largest email providers coming to me saying, hey, how do I make it really inexpensive to be able to use one of your models to run through lots of emails, right? So they eventually picked up a 7 billion parameter model to actually use. So it really depends on your use case and how expensive you want to be able to do things if you're a data science person. But if as a non-data science person, you wouldn't have to worry about too much about it. Prompt design, a lot of the stuff is very much what everyone will be doing. And supervised fine-tuning, so a lot of these work requires you to have some labels to be able to do. So I think when I was leaving Amazon, we were training one of the largest models available. I think it's like in the hundreds of billions of parameters. So I was in charge of running RLHF at the last few months. So I mean, this work is quite advanced and quite difficult. But very few people, do not wish lots of people to be able to do these things. But so supervised fine tuning, so you would have labeled data and really high quality data. You would be able to do supervised fine tuning, and then the hard part is the RLHF. So people have heard of DPO and some of these methods, right? So they are really difficult to get right. And then finally, you might want to distill some of your models, and distillation is relatively inexpensive. So you're essentially taking a really large model, taking the output and used as a teacher model to train and distill these smaller models. So that's another method people quite use very often. So we do support that. So there's a distillation support over on Vertex. And also, things like full fine-tuning. So we also support things like, side-by-side model evaluation. Essentially, looks at the output from multiple models and to see how good they are. In terms of developers, I think the key things you guys are going to be looking at is, RAG. So there are so many different ways of doing RAG. And I think there's a new way of doing RAG every 5 minutes. And then there's grounding. So grounding is a feature that GCP offers. And then there's function calling. So there's a lot of function calling capabilities. I would think that is really one of the most exciting feature of these very large models and the ability to offer function calling. If you look at the latest Llama models, I mean, of course, Gemini has a very powerful function calling, but if you look at the latest Llama models, so they support Python, so you can call Python directly, and you can also call Mathematica. Isn't that amazing? So the reason is because there's a benchmark that people are comparing how well these models do for math capabilities. And then I think it also has a search. There's a Brave search capability, so you can actually do search. So as you can see, those are the basics of function calling in these really large models. But as these things evolve, as people kind of build more and more of these capabilities and fine-tune them to be able to do function calling, I would imagine in the next 6 months, I was thinking about years, but 6 months, you're going to have the ability to do function calling on hundreds and hundreds of APIs. So this is what I see in the future, and it'll make your life much easier. Software development will be really, really exciting in the next few years. So we already talked about a lot of these things, and I think the key thing for you to take away is that model discovery is really a very interesting place to start playing with different models. And I would say different models still have very different capabilities today, and they have different personalities. And another thing is that they all have different filters. So I would definitely try as many models as you can, and for what you need to do. So there's just so many of different models. The reason is because these models are trained on different data sets, and they're very different data sets. So for example, Llama is trained on 15 trillion tokens, and Gemma is trained on certain data sets that no one else has. So definitely try different models to see if they do things better for you. Don't look at just the benchmarks. If you look at the benchmarks, everybody's competing on 5 or like 20 of these benchmarks. But underlying, you should really look at what these models are actually built upon. Right? What kind of data sets they're actually using versus what they're really good at, and who trained them. What are these guys good at? Are these guys computer vision folks? Are they have a really a strong a background in, say, geospatial science? So it's just really I think this is a time where these domain specific kind of models also would shine. I think with that is, I would encourage you guys to, try Model Garden. Just do Google search. So when I first joined Google, I asked them, where can I find stuff? They said, we're a search company, just search. Yeah, so, I think I was, told this, just let me Google it for you. I think that was the word that I was constantly being told. But so again, go use Google, find Model Garden, and take advantage of the 405B model. And I would love to get feedback from you because we're just starting to build out these model as a service for open source rather than I'm just me. So all these things are just like 1 p.m. covering all of it. So I would love to get your community support on it. So any feedback you can provide to me by going to I think I have also LinkedIn and also on Twitter. So I'm both on there. So love to connect with the community. I'm open to answering a few questions. You can ask me anything. So any takers? There's somebody in the back. Yeah.
Can you give a general sense of how well supervised fine-tuning works for LLMs? I've heard conflicting reports on how they. The reason why people use RAGs is maybe because the supervised fine tuning doesn't work as well. I've heard hand wavy explanations of LLMs have too high of a dimensionality and whatnot as to how well fine tuning works on them.
Yeah, so I think there's really, I think there's like several layers to it. So one of the things I forgot to mention is that one of my the person that was originally supposed to be speaking here, Keelan, is our outbound PM. So she is taking this CS class, and she showed me something that really blew my mind. She took like hundreds of slides and all these class notes and dump them into Gemini Ultra to, try to break the 2 million, context window. And it didn't. And it worked so amazingly well. So when I looked at it, I just said, hey, I have faith. I have, more faith in Google product than yesterday. So I think having these long context lens, and I think that might just be the brute force way of solving things because they're so easy and so simple to solve. And that's just one answer. But your original question is about why does supervised fine tuning not good enough? The reason is because you are essentially updating model is hard. It just really is the like the best answer I can provide to you. Like we even with some of the best scientists, so quite a few of my old reports work at Meta now, building out llama models. Even the best science people, when you do fine tuning, it's not a trivial amount of work to be able to do it. And also just that your data is never clean and good enough. It depends on how much time you have to spend on gathering good data versus just good enough, right? So in a sense, RAG is not really an AI application. It's more like a database application. One of the interesting things we saw was things like OpenSearch. We saw hundreds and hundreds of thousands of deployments, just people doing because it's easy, and doesn't mean it works better. It just means it's easy. That's why I think RAG is so popular. I mean, it's not the best answer, but I mean, easy is always so much better than something that's slightly more complicated that requires people to do something. So anyway, so another question? So I think I saw her hands first, or okay, I'll let you, Josh, do the policing there.
Hi, Wenming. Thanks a lot for such a nice presentation. So my question is two-part. First part is, does Vertex AI have any plans for supporting adapters along with the fully fine-tuned models, which would actually solve the problem with cost and like the training?
Yeah, I was just, literally 10 minutes ago telling my dev that we need to support adapter fine tuning. So the adapters are a little difficult. The reason is because the 405 models, 405B model is really big. It just barely fits into one instance. As soon as you go to second multi-host, it becomes a problem. And by the way, this is not a problem on TPU. TPU guys kind of solve some of these problems, but then I would require like 12 hosts to be able to do it. So it's just like infinitely difficult. So TPUs, I don't know if you're familiar with TPUs. The TPUs has 16 gig. I love hardware. So TPU has 16 gig times each 8 hosts. So if you multiply it out, that's 100 some gig of memory, right? So if you're 405B, you multiply that by 2. So if you do a BF16, so you're looking at, after you add KV cache, all of that, suddenly you're looking at like, dozens of hosts trying to, run these models. And it just, for me, it becomes a little hairy. But TPU apparently can handle it really, really well because of the networking, the networking we designed. So to answer your question, yes, it is good. And also there's another, if you want to do it yourself, I mean, I certainly, it's open. Look at Punica. There's a paper called Punica by University of Washington. So essentially, it allows you to serve thousands of adapters using just one. So it might get implemented in VLLM. So we're simply using VLLM. So we do a few extra things, but the VLLM guy also works for us, so that's a little different, a little advantage there. But so again, adapters are coming, but any kind of services, you're going to have limitations because it's a service, it's not a solution. So if you want to run it yourself, essentially what you have to do, even with the 70B model, you can use things like VLM, use the Punica kind of the feature turned on, and then you would be able to host a lot of adapters yourself, or you can use our solution. As we're not likely to provide adapters for 405B. The reason is because when you are at that size of the model, very few customers have the science capability to actually do better. So that hopefully answers your question.
Yep, definitely it does. Thanks. So my follow-up question is that VLLM, as you mentioned, supports multiple adapter support, but I guess the dynamic adapter loading is still in experimental stage with both TGI and VLLM. So any plans for supporting frameworks like Lorax for that?
Sorry, I didn't quite get. If you can speak a little slower, yeah.
Yeah, sorry. So as you mentioned, VLLM for adapter support, I think the dynamic adapter loading is still in an experimental stage with
Right.
VLLM and TGI, but frameworks like Lorax does support it completely. So any plans for supporting such frameworks along with TGI?
Yeah, so all those things are kind of in the works. So part of it is that if you add adapter, a lot of stuff, it takes like it becomes slower as you go. But so I think the future is going to be, the Punica-like implementation, and I think if the community works on it and do it properly, I think that's probably the right way to do it. And also, there's another implementation called TVM. So you may have heard of a company called OctoML. So Octo folks, so they might co-chair at a conference called MLSys. So I also run MLSys as a sponsor chair and been running it for 5 years. The TVM may support it. You can certainly take a look at it. It's great to play with it and be able to run stuff. There's another thing about operating things that break. So definitely try to use the services as much as you can. But like I said, I'll also be happy to answer questions offline if I didn't quite answer your question there. All right, thank you. You had a question, yeah.
Let's take a couple more questions.
Yeah.
Hi, thank you very much for a very insightful presentation. I really enjoyed it very much. My question could be very fundamental, but I have a questions on performance evaluation matrix that Vertex AI provide. So I think the Vertex AI performance matrix, evaluation matrix provides algorithm for both predictive AI and generative AI models. And just wanted to understand how the matrix work differently between those two different models.
Yeah, so I don't have a good answer for that. So right now, there's a lot of things being kind of what is it called, worked on. There are certain parts of Vertex I'm not very familiar with, so probably I have to take that offline. But in terms of if you're asking questions about evaluation, evaluation for LLMs, I do have a collection of benchmarks and also, essentially using large LLMs to do evaluation. I'll be very happy to send some of that to you offline because it's a relatively complex topic, and I'm constantly getting what is it called? Pain from our internal evaluation, and there's also what is in the product versus what is out there. So sorry, I didn't quite answer that, but I'll be happy to answer some of it offline. So it's just that there's legacy parts, there's different parts that makes it a little difficult to answer that question. Yeah. Yeah. Sorry. Yeah.
Last question.
Yeah, sure.
And you're going to be here a little bit after.
Yeah, I'll be here to answer questions.
Hey, thank you for the wonderful presentation. Just had a question on infrastructure since you were talking about H100s, and you probably need, a dozen H100 instances for this. What is your scaling strategy? I'm guessing one model takes a dozen instances, so it probably can't serve all of your customers. And at some point you'll hit throttling. So what is the strategy to sort of make sure that your capacity is always available?
Are you talking about like model as a service as API calls, or are you talking about like providing them for you to run things as a virtual machine?
So I'm talking about GCP, right?
Yeah.
You probably have limited capacity to serve your customers. So what is, let's say hypothetically, you run out of H100s. What is the strategy after that to sort of scale beyond a certain set of customers?
That's a really good question. So capacity is another, 20% of my time trying to find capacity. So in terms of capacity, I do have capacity, but maybe I didn't quite answer. It's a little hard for me to hear. I would say that there's all the cloud providers have very complex ways of allocating resources. And I don't really, I think it really depends on the situation. So, there are really large customers that would, buy these things. I mean, it's like true for AWS and also, Azure as well. So there's these really large customers that would buy a bunch, right? And then there's things like that are on demand. But the on demand is kind of like, there's also spot instances. So you're going to see a lot of that, as H100 capacity becomes more available in the industry, as people kind of move towards the newer capacity. I also saw in the news that not H200, so B100s and B200s are all delayed. So they're all delayed by 6 months or 3 months or God knows what. So there's probably going to be a capacity constraint until then. But in terms of how things are being prioritized, it's a much harder question.
Sure.
I don't even know.
Yeah.
So
It's just interesting to think about
Yeah.
these scenarios. Is there also a fallback to TPUs in your case where?
Yeah, so TPU is a very interesting story at GPU. Sorry, at Google, as versus GPU. So Google has a lot. Google Cloud has a lot more experience. Sorry, Google has a lot more experiences running TPUs, and TPUs are almost mythical. I would even go as far as saying that I didn't see TPU for the first 3 months of was at Google. So, but then after a while, we have capacity. I mean, there's like TPUs. So TPUs are actually very inexpensive. They're very inexpensive. I don't know what the pricing, like the cost of silicon is like much cheaper. But the thing is, it depends on what kind of models you're trying to run. So TPUs, the V5Es, they're 16 gig per chip. There's 8 chip in a board. So they're really designed for these smaller models. So the V6E, which is interesting, there's 32 gig GBM, and those are all public released. And there's like additional 2 versions I can't talk about, but future versions will have a lot more memory. But these 2, they were designed not necessarily inferencing for, but even with that design, they're still far, far faster than GPUs. And if you actually look at it, it's really, really fast. These, ASICs are faster because, they don't have to do the graphics, right? So they're just so much faster and so much cheaper for smaller models, but for large models, they're different. And there's another caveat to it, which is Google is really good at running TPUs, but Google Cloud has some gaps. So you'll see there's like Jetstream, and then there's another project called HexLLM, which is under me. So I own it, but I can't open source it at the moment. So if you want to run any kind of TPU workload, you want to go to Model Garden and pick TPU there because it's running this thing called HexLM, and it's just way faster and cheaper than everything. But the only problem is that your quota might be only limited to four TPU out of the box, which is 64 gig. So, I mean, it's just, pros and cons, right? But with one A100, you're, at 80 gig.
80
so,
gigs, yeah.
Yeah. So anyway, so hopefully that answers your question. There's no easy answer.
Yeah,
to
this is the
everything.
biggest problem. Even like at my workplace, I see this a lot where customers are like, we just don't have capacity for.
Yeah, but
GPUs.
it's really, I would, the last thing I would, comment is that it's a really exciting time to be in tech, and especially working on LLMs. Regardless of what you're working on, definitely, find your niche, and you'll be rewarded. Just take that patience, and you'll be rewarded for your career or your satisfaction of working on something really interesting and that you love. So with that, I think I'll hand it over to the other speakers.
Thank you.
Thank you. Yeah, as I said, thank you, Wenming. As I said, yeah, he's going to stay here a little longer and then answer any questions. In the meantime, we're going to be getting ready for the next speaker, Dave.
All right, let's give this mic a test. How does that sound? Sound all right? All right, good, 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 good. So, okay. All right, well, hello again, everybody. I want to spend, I don't know, 15, 20 minutes or so talking about GitHub Models. This was something that we just recently launched with a blog post last week. This is going to drive me crazy. Where's the blog post? Yep, we had, when was this dated? August 1st. So yes, just not even a week ago, kind of a thing. When I saw our announcement for this and thought about, AI Camp coming up, I thought this is going to be the perfect audience for this. So let's kind of dig in and see a little bit here about GitHub Models. So if I come back over here, play this video first. All right, so what's this all about? Well, we are enabling the rise of the AI engineer with GitHub Models. We want to bring the power of industry-leading large and small language models to our more than 100 million users directly in GitHub. So not every developer has, the top of the line MacBook or access to powerful cloud GPUs. But at GitHub, we believe everyone should have access to the latest AI models so they can build and learn for the future. So this commitment aligns with our mission to democratize development by providing essential tools and resources such as free continuous integration, continuous deployment, and code spaces entitlements. Are any of you using code spaces today? See, just a few hands there. So code spaces is Visual Studio Code running right inside of your browser. And it's connected to your GitHub repository. So I can have a code space configuration for one application that's a Java app, and maybe I need to always run with 6 or 7 different Visual Studio Code extensions. I've got another app over here that's a .NET app, and maybe I only need 4 or 5 extensions for that. I can easily switch between those very quickly. Or as a new developer, I can start a code space in a matter of seconds, as opposed to going to our company's internal wiki or Confluence page and says, well, when you get started, make sure you load all of these extensions. So yeah, you're up and running and working on code in a matter of a minute or two, kind of a thing. Now, in this new interactive model playground, students, hobbyists, startups, and more can explore the most popular private and open models from Meta, Mistral, Azure OpenAI Service, Microsoft, and others with just a few clicks and keystrokes. And with the suite of models, developers will have the options they need to stay in the flow. You don't have to be switching around from different apps and things like that. So you can experiment more and learn faster than ever before. And this is just the first wave. So in the months ahead, as we approach the general availability of GitHub Models, we'll continue to add more and more language, vision, and other models to the platform. So this is going to allow you to experiment, compare, test, and deploy AI applications right from where you manage your source code. And you're going to be able to spin up code spaces to bring your ideas to life. So the fun doesn't just stay in the playground. With the power of code spaces, we've created a zero friction path for you to experiment with the model inference code before dropping it into your own project. With sample code for a variety of languages and frameworks of all types ready to go, you can try out various scenarios without ever hitting that works on my machine problem kind of a thing. And in alignment with GitHub and Microsoft's continued commitment to privacy and security, no prompts or outputs in GitHub Models will be shared with model providers, nor used to train or improve the models. All right, so there is a little demo video. I'll play through this demo video, and then I'm also going to, pop in there and do some poking around, so you can see this is real. It's not just smoke and mirrors and things. But let's get this started.
Right tools and training. We believe that every developer can be an AI developer with the right tools and training. That's why we've launched GitHub Models on the GitHub Marketplace, a place for you to explore and experiment with a hand-picked collection of top models with entitlements attached to your GitHub account. So let's try out one of the newest models, GPT-4o. We can pass in an initial user prompt to interact with the model, and we can use the playground to adjust the parameters. For example, we can change the system prompt and experiment with the temperature for more or less randomness. Now that we've adjusted the parameters, we can send you with the model, simulating its use for our application. Now GPT-4o looks great, but I want to test how a different and smaller model handles this scenario. So let's switch to Phi3 Mini Instruct and evaluate its response. Looks good. Now we can also navigate to the details page to find out more information about the model through the README, evaluation, and transparency tabs. Now I've made my decision and I want to start using the models with code. By clicking the code button, we get access to some getting started instructions. We can even use a GitHub codespace to create a pre-configured development environment, ready with SDKs and some samples. Now the model API calls use the entitlements that come with my GitHub account. And because the codespace knows who I am, I don't have to add an API key or sign up to any other services to start experimenting in code. Talking about experimenting, let's update the streaming sample to use Phi3 Mini 4K Instruct. We'll also update the prompt and continue with our experiments. Now those entitlements we mentioned earlier follow you wherever you're logged in, including the GitHub CLI. Here, we're calling AI models to create questions for first-year computer science students so they can check their knowledge of Git. But we can even combine other CLI commands with the GitHub CLI. For example, let's summarize the last 10 commits of this repository using Phi3 Mini Instruct. GitHub Models helps minimize the friction as you explore and experiment with AI models. So take your first steps in building AI-powered apps by joining the waitlist for GitHub Models. We can't wait to see what you build next.
YouTube always gets in the way there with the inline links and things. All right. So prototyping with AI models. You can find all the models on the GitHub Marketplace. So if I go over here, I have the marketplace open, and this is where you would go for, last time Sharon was here talking about Copilot extensions, right? So if from GitHub Copilot chat, you want to ask the Atlassian extension about stuff that's in Jira and Confluence, you can do that. If you want to ask the Azure extension about, hey, how many OpenAI services do we have deployed so far, right from GitHub Copilot chat, you can do that. But it's also where you would find, GitHub Actions and apps for integrating with things like Jira or Azure boards and things. But now there's this new models section right here in the marketplace. There we go. Things are going to fall apart on me. Here we go. All right. So as you can see in the models here, I think I counted like 28 different models right now. But like I said, this was just launched 6-7 days ago. What's today? The 7th? Yeah, this was just launched 6-7 days ago. So we definitely see this expanding, but Cohere, Meta Llama, different versions of the models, Mistral, OpenAI Chat, GPT 4.0, 4.0 Mini, different versions of the Phi3 models and everything. So, you can play around with these different models and things. So now we can test and compare things right in the playground. So let's say if I go into OpenAI Chat GPT 4, I've got the README and everything here about it. I can dive in and learn more about it here, or look at the evaluation criteria that's out there for this model and compare that with other models and things. I can see the transparency statements about that model, look at the responsible AI considerations, content filtering, et cetera. But if I go here to the playground, we can see that I can pop right into an environment where I can play around with this model. So depending on the model, I'll have different system prompts and things that I can play around with, play with different settings and things. So maybe I'm going to start out here and say, you know what? For this round, provide all responses as if I'm an elementary student. So I go in here and say, what is artificial intelligence. And it's going to give me, pretty basic kind of response, right? Artificial intelligence or AI is when computers or robots try to do tasks usually meant for the human brain. Imagine if your computer could think and learn a lot like you do. For example, AI can help a robot understand commands, figure out puzzles, even play games with you. It's like giving machines a little bit of thinking power. But now if I change that system prompt and say, hey, rather than responding as if the user's an elementary student, what if the user is actually a PhD, working on their PhD in a computer science program? So now refresh, and I will ask that same question again. What is artificial intelligence? I'm going to get a different style of response, right? It's going to, let me try that even again, because of course, probabilistic, not deterministic, right? Because when I was doing this earlier today, it was giving me, there we go. That's similar to what I was seeing earlier today. Talks about narrow AI versus general AI. It goes into machine learning and neural networks and things like that, which, an elementary student's not going to know what half those words even are. So yeah, you can play around with system prompts. You can play around with, number of tokens and things like that. Now I could even go back up here and say, all right, let's play with, let's see, phi3 medium instruct here. Here we don't have as many parameters and things to play around with. So, maybe we change the temperature to control the randomness or whatnot. And try that out, see what kind of an answer that gives me, kind of a thing, and a pretty basic answer there. But it doesn't just stop with this playground, right? I can, so let me double check my notes. Yeah, so test and compare different models in the playground and everything, but I can also bring things into one of these code spaces. So here, if we say, actually, let me go back to the GPT-4o1, say get started. Now it's showing me, okay, what would I need to do in an application, get my personal access token to talk with it, or to be able to connect with that, and say if you're in PowerShell or different languages and things, install the dependencies, run the basic code, I can go right into this code space. So when I say run code space, it's going to give me an option here to say create a new one. Now I actually created one this afternoon. Even if I create a new one, it's only going to take a couple of minutes to spin up. But just to save us time, I created one earlier. So I'll say resume this code space. And again, I'm right inside the browser. I could be doing this from my iPad if I wanted to, kind of a thing. And it's going to come in. Here's my Visual Studio Code environment. And one of the things about the way these code spaces work is right inside of your repository, you have this dev container.json file. And this is where, you say like what different extensions do you want to automatically install and everything. So, maybe your project leads or your senior developers, your architects kind of set up this configuration. You can bring on developer after developer and they're working with the same environment, right, to do all of this. So now that I'm in here, I can see, okay, how do I get started with these? Right now, we have support for JavaScript, Python, and curl. There'll be support for other things coming and whatnot. But there's sample code built right in here for curl, JavaScript, and Python, and things like that. So if I go in and look at the README under Python, Then I've got some, more specific information here on, okay, how do I get started? And here's some examples for OpenAI, Azure AI interface, Mistral, and things like that. It even gives me a command here that I can run in terminal, that is going to run this multi-turn Pi application kind of a thing under, where is it at? Somewhere. Samples, Python, Azure AI interface. There it is, multi-turn PI. So if I take that and just go into my terminal and paste and run that, now I'm running an example of this, and we could go look at that code, just return the capital of Spain, but we could go in and look at what that code is doing and everything that's needed to connect with that model and run that model. And then we could go in here and play around with different prompts and things like that, make it very easy to do all of that. And again, be able to do that with different languages and things. All right, let me look at my notes here. So another thing, so you've got the code spaces and everything, but you can also experiment with the AI models using the APIs and such. And so there are rate limits on using the APIs, because this is just for learning and experimentation, getting to understand how to work with these different models and things. This isn't where you would actually do this in production, but then we do provide a path to take it to production. And the path that we have for you, of course, is through Azure AI, OpenAI service and things like that. But, once you've learned how to do it here, you could go to other providers and things. Once you get a sense for how to build this into your applications, how to work with the APIs and other things. So this just launched into kind of a private beta. So what we're doing right now is we're looking for your feedback. How else can we help you? What other features, what other capabilities should we build into this service? So here's the QR code and the shortcut URL to sign up for this service. And right now, everything is free. Just like if you're building out open source libraries and stuff on GitHub, that's free, right? So this is free. So I'll let everybody get a picture there. All right, and so the other thing I will do is pretty much right after we're done, I'll save a PDF of this presentation and put that in the Seattle channel in Slack. So you'll be able to get access to that QR code again, but also get access to all of these resources, the announcement blog post from last week, the documentation that goes into more details, a direct link to the marketplace that we went to and were playing around, the direct link to the wait list and things like that. And then our discussion group as well. So, let me go back. I see somebody taking a picture there. There you go. So one of the things we added to GitHub a couple of years ago was GitHub discussions, and it's a discussion board, right? So we leverage that to collect feedback on all of our different capabilities and products and stuff. So we created a category out there for models. So already you can see introducing GitHub Models. We want to find out what AI models are you interested in? So you can go in there and give us your feedback, right? And we'd love to see. And even somebody's already reported a little, issue that they've seen out there and things like that. So this pretty much gives you, direct channel to provide feedback directly to the product group that's working on this and everything. So, yep, and we see a number of discussions already out there, even though this has been out there for about a week or so. All right. Now, that is what I have this evening about GitHub Models. So we'll see if anybody has any questions. Does this look useful? Are you going to sign up for the wait list? How many are going to sign up for the wait list? All right, that's what we like to see. That's what we like to see. Awesome. Awesome.
All right. Thanks, Dave. Any questions? Don't be shy. Up.
Yep, got one over here.
Thanks for the talk, Dave. I was just wondering how long it's going to be free for, or if it's always going to be free.
I believe, well, I shouldn't say it that way. My understanding is there will always be a certain aspect of this that is free. I mean, if you think about GitHub and open source and that, you can use many of GitHub's capabilities for free for developing open source. And like I said, going back to our mission, we want to empower developers to be able to become AI developers, right? So you'd be able to use this for learning, playing around with models and stuff like that. When you want to take something to production, then you'll have to look at signing on with Azure OpenAI service or something like that.
Thank you.
All right. Going once, going twice.